feature encoding is a technique that is applied on text variables, on qualitative variables, in other words, like the example given to you here. If you have, let's say, a column which indicates whether, let's say, a type used is pen, pencil, eraser, or maybe the the creature is dog, cat, or cow, and so on. So the point is we have categorical or qualitative data. In this case, we need to find a way to represent or map. In other words, we say mapping categories into numbers because algorithms prefer numbers. We have two types of qualitative data type we discussed about last session. We have nominal and ordinal, or some previous session. Okay, so you're supposed to be already aware. So let's look into example of nominal. If we have a team, let's say records of matches, football matches for different teams, and let's say the score or the points they achieved. And then we want maybe to study some relationship. Of course, this is just a sample of the data. There must be other columns and objective and so on. But the point is, how can we treat this qualitative column? Since it is qualitative, we need to determine first whether it's nominal or ordinal, because based on the data type, they have different way of mapping their values into numeric. So in this example, if we assume that teams have no natural order, then we can go with nominal. And for nominal encoding, only we are restricted to use 0 and 1. So you cannot use 1, 2, 3 because you don't want to give the sense of ranking to the algorithms. So in this case, we check how many options are available. Okay, and then based on it, we build, we do for each one. Okay, so for team A is going to have their own column, team B own column, team C, and so on. Okay, based on the number of categories you have under that specific variable. And then what do you do in this case? Only you are going to, when you try to represent each record, you check what is team, what team is for the first record, team A. Then you need to replace or put under team A 1, the rest 0, 0. Second record is also 1, 0, 0, and so on. So 1 here represent either exists or doesn't exist or absence of presence. Okay, so there is no nature ranking here, natural ranking. Okay, for ordinal, in case if you have ordinal, since ordinal has the nature of ranking, then we can go with ordinal encoding. And in this case, we can just use numbers 0, 1, 2, 3, okay? Because we need actually to indicate that there is nature of ranking. So in other words, 2, the algorithm will understand is higher than 1, higher than 0, okay? So the nature of ranking is there. Okay, can you notice anything between nominal encoding and label encoding? If you check label encoding, you would notice that we have a lot of zeros inside the matrix or the features that we have generated. Okay, we have a lot. So this actually is a problem, can be, where you have sparse data. If you remember the word sparse. If you say you have sparse data, meaning you have a lot of zeros inside, and this can actually be a problematic, especially if you have, let's say, the team column, and it has quite many options. Let's say 100 teams inside, then that means that needs to be converted into 100 new features and a lot of zeros inside. A lot of zeros can make a problem in training your data. If your data is sparse, then very difficult to find the patterns inside the data. Okay, not to mention the space that's going to consume in the memory. This is why when we saw during the practical session that it has special representation to compress the values inside the memory. But anyway, sparse data are still there during training time. Or here, since nobody asked, we have also what's called label encoding inside scikit-learn. So you can use ordinal encoding or label encoding. The difference between them, ordinal encoding, when you use it, allows you to have a predefined ranking. I mean, you can define or declare to ordinal encoding how the order is, who's first should be. Okay, you can specify rather than having the encoder to do it by itself, because when you use ordinal encoding, it's going to just randomly assign unique values to all categories and may not be actually corresponding to the right natural order. It may not correspond correctly to the right natural order. So ordinal encoder allows you to define the order of your categories. So when you create here, you can later go and check. There's one argument. When you define ordinal encoder, you can specify the order of your categories. Okay. While label encoder, this one doesn't have this feature. Okay, and usually it's used with target variable. But anyway, label encoder doesn't have this capability to assign the right order for your categories.